And namaste, everybody. I thank all Utsahins for giving me this opportunity to interact with you all for the next 15 minutes. I have timed it for 15 minutes.
Yeah.
Anyway, I think definitely I will be able to transfer some of your ideas and share with you all also. Now, before I begin my presentation, I would ask a general question. What is the aim of teaching mathematics? As Mr. Raghuramji rightly said, it's always a scary subject. Children definitely, many children develop a phobia towards mathematics. And it is considered to be a dreadful subject, though it is such a beautiful and applications in everywhere. On one side, we'll say it is the queen of all the subjects. And one side, we'll say that once the mathematicians can learn anything. Of course, it is not with other subjects. This is one complement for the subject. And there's another side is it's always the children find it very difficult. Why have you got less marks in mathematics? All the subjects I got very good marks, but not in maths, ma'am. I don't know what I'm getting it. Why I'm not getting it? I don't know. I remember everything, but I'm not able to do it in my exam. This is a very, very common comment that the children make after finishing an exam or so. So leave alone all that. Let us do our best in order to create an interest in the children. Okay. Now before that, what should be the aim of mathematics teaching? Can anyone tell me? The aim of why should we study mathematics at all? The children ask this question. What answer you will give as educators? So we can say that mathematics education has got two aims. So one is a narrow aim, one is a broad aim. What do you mean by this narrow aim? The children study mathematics, they get very good marks, they take up some job, and then they get well placed in life. So they are able to contribute to their living and also to the society they are living. Now, what is the broad aim? So that we have to find out. So what is the broad aim that mathematics education develops, or the aim of mathematics teaching in order to develop the broad aim of the students? So we can say that it develops lots of skills in the children. It improves their thinking abilities. Then it gives a very, very broad picture of anything. They are able to arrive at some procedural followings, isn't it? One step, the next step. They're able to structure a problem. They're able to analyze a problem. They are able to find a solution also, and solution in different perspectives. If that is the case, how are we going to offer this package to the children? So analytical thinking improves, and then their creative thinking abilities improve because of mathematics education. And then they are able to find the connection of mathematics with in everybody's life in some way or the other. They are able to handle the abstractions. So mathematics offer a variety of ways of doing things, and it develops the right attitude also to one's own problems at different levels. So this is the higher aim that the mathematics automatically develops. The education, mathematics education automatically develops. And that is the process of mathematization of the mind. So how do we think mathematically? Any situation for that matter. You have asked me to log in at 6:55. So I was constantly working on the time. Mathematics is applied. So there is a meeting arranged in a room set. So the mathematical mind, what will think? How many people can be accommodated? Where at the stage? And then how many people are going to speak? How do I time it? And then where will I install the mic so that the volume is at the maximum reach? So this is the mathematical calculation. So one beauty is mathematics is a subject which is applied. I'm not saying that it is light. It is applied by even the people who are not learning mathematics. Everybody in some way or the other, we have to live mathematically. We have to apply mathematical concepts in our day-to-day life. For example, you just get up on the clock space, then finish all your morning routines, go to the breakfast table. If you get a very good food, You will enjoy it. If the food is not up to your choice, what you will immediately think? That proportion is not made correctly. The ingredients are not put correctly. Even for making coffee or tea, either it is too much of milk, it's not the right proportion. Automatically we say that it is too much of sugar. If more than 1 spoon you have put sugar, or less than 1 teaspoon you have put sugar. So every time or the other. So we use mathematics. You go out, you do business, you go to the bank, mathematics apply. You go for shopping. Again, you have to do the calculations on commercial mathematics, sale, all these things you must know. And then you have to reach a particular place. You have to calculate that speed, distance, and time. So I have got only 5 minutes left. How do I reach that place? So definitely you have to make the calculations, whether to go by walk, whether to go by cycle, or to by any other mode of transport. All these things you have to work out. So that is the mathematizing the mind. Okay, but what exactly is happening? The at school, the children are not able to develop this connection in mathematics in their day-to-day lives. So children think that the mathematics is available only in the textbook. It goes beyond the textbooks. It is applicable everywhere. The world, the nature revolves around a mathematical rhythm. Everywhere, whatever we see, the high buildings in architecture, in what field maths is not applied. And moreover, in the emerging fields like artificial intelligence, coding, mathematics is involved. These are the subjects which are going to be popular in the next few years. Again, mathematical knowledge is important. So how do we do this? How do we take this to our children? You have to offer a variety of, as educators, variety of methodologies, variety of approaches, pedagogical tools. That's very essential for an effective mathematics education. Now, one thing I would like to share with you all. Will you give the permit to share my screen with you all?
Yeah, you already have, ma'am.
Yeah.
Yeah, you're the co-host.
Can you see my screen? Can you see my screen?
Not yet.
No, no, ma'am, not.
Yeah. 1 second, please. I'll come back.
Yes, ma'am.
Now, a simple question. You are seeing a chessboard right in front of me. So many people play chess. What is the connection with chessboard and mathematics? Connection
Uh,
of chessboard with
the
mathematics. You
shape,
can frame number of questions depending upon your critical
yeah,
thinking ability. How
true.
with the two squares? So many questions. So how many black squares are there? How many white squares are there? So like this. Suppose if I keep one gold coin in this first square, say, in the next square I keep 2 coins. So it is 2 power 1. The next is double it, 4. So like that I keep on double every square, and by the time I come to the 64th square, you know what is the number of gold coins that I have accumulated? Look at these calculations. It is 2 power
India's budget.
64 minus 1, which is an amazing number. The result is it is 18,367,728,398. Can we ever imagine such a number? But we are teaching large numbers and things like that to the children. So like that, Max has got a connection everywhere. Now, can you tell me what is this? The picture that you are seeing here, what is the mathematical connection of these two pictures? So what is this picture? This is
Pattern?
a pattern, I agree, the symmetrical pattern. But this particular pattern is given a particular name. It is a
Mm.
fractal. What is exactly fractal? Fractals are the miniature shapes of the major figures. So this is a natural fractal which we can see in the sky through the telescope, especially early in the morning and evening twilight time. And then this is a natural fractal that we can see from the sun's rays. And then this is a man-made fractal. You know what is so peculiar about this fractal? This has got a special shape. This shape is hexagonal fractal. Everywhere we find hexagons only, it is a miniature. So that is how Max is connected in every way. In every, you want to beautify yourself, Max is needed. You want to beautify your building, your surroundings. You want to create landscaping in your garden. Definitely, Max is needed. Everywhere you want to create some toys in the garden to play like a swing and slide. Definitely, Max is needed. So everywhere Max is applied, and we cannot mention any one field where mathematical applications need not be found. Now, how do these mathematical abilities or mathematical skills can develop? I feel that everybody, every human being is born with some latent talent in maths. Like how the child learns a language, the child can learn mathematics. How? Any newborn can easily identify between 0 and 1. So he may not understand the symbol or whatever we show, but the concept is very beautifully understood. The mother gives one thing, the child is able to say it, think that it is one. If the same thing is detached from him, he says there is nothing, it is 0. So the mathematical number concept can be easily taught through these skills. So what are the basic skills with which we learn anything? And that too, these are the basic skills that are associated with the mathematical learning skills. So one is matching, second is sorting, third is comparing, fourth is ordering, fifth is subitizing. These are the 5 basic skills with which the children starting from pre-KG level to even the college level. So maths is learnt only by these 5 fundamental skills. So here matching. Matching is the establishing the connection, like one-to-one connection between the two objects. So definitely a child of 3-4 years or even before he is going to school, say. So you give him some objects. He is able to match a cup with a spoon. Okay, a head with a cap, your shoes with the socks, your shoes with the lace. So that matching is already there in the child. What about sorting? You give him a collection of objects. Ask him to sort out the different objects. He is able to sort the objects that he is being given to. A children of 2 years, 3 years, before they go to school, they obtain these skills. So next is comparing. Definitely the child is able to compare. You give him a bigger piece for the child's sibling and a smaller piece of some eatable or some favorite item to the younger issue. Immediately he will start thinking that this fellow has got a longer piece, I have got a small piece. He may express or he may not express. So he knows to compare things. Hot and cold. So if you give a hot coffee, he can find its taste. If you give him a cold ice cream, he enjoys the taste. So he is able to compare between the two contrasts. Heavy, light, smooth, rough, big and small. The children are able to distinguish between these two items. Next is the ordering. So ordering is the foundational to our number system. So children are able to put the items in order. Give him a marking. This. So he'll arrange from small to big or big to small. So that definitely that faculty automatically the children will get before the age of going to school. So this is a very, very beautiful skill the child has. Seriation. So what is that seriation? Arranging from small to big, arranging from big to small. The children are able to seriate the objects. They are able to order them by size, length, or the height. When giving a child directions, the ordinal words, first is associated with 1. So like that the children are able to do the seriation. So these are the 5 basic skills that the children are born with. As and when the age grows, they develop in higher proportion, like that is automatically it gets streamlined. Okay. Now another thing is very, very important skill that the children learn along with mathematics is subitizing. What is subitizing? You give him a collection of items, some items. Without counting 1, 2, 3, the ability to understand how many items have been given to him. So that is subitizing. Maybe for an younger child, it may not be so much, but as and when the child grows, this skill can be developed. So even without counting, the child enters into a classroom, say. So the child can roughly count how many numbers, how many are there in that room already present. So that is the subitizing ability. So with all these 5 basic abilities, the children can learn any amount of mathematics that we teach. Now, another thing is, mathematics is always associated with sense, number sense. So what is number sense? These are the benchmarks for counting I have given. Ages 2 to 3, the children will be able to count objects from 1 to 3. So that is also inborn. So naturally the child can be trained. And then age of 4, 1 to 10, backwards and then forward counting. Age 5, 1 to 20, back and forth. Age 6, they attain the skill for 1 to 100. So the basic skill is the benchmarks of counting at various ages we have to fix, and accordingly we should train the children. Now another thing is the number sense. So the number sense is, we all say, write the number name, convert into numerals. So this kind of exercise we give to the children. So the children have to first, how to develop a proper number sense. First they have to understand the numbers. That is how the number is formed. Suppose if they should be able to clearly find out difference between 99 and 9. 909 and also 999. 909 is always confused with the 990. So these kind of confusion should not be there in the children, that we have to develop as teachers, as educators, I can say. So number understanding is very important. Then the second thing is number comparisons. So children should be able to compare the numbers. They should know that 98 is more than just 8. 98 is bigger than 77. So the number comparisons is so essential for the children to acquire enough mathematical skills. Next is the number formation. How the numbers are formed. Adding 1, 1, 1, 1, 1, 1 to the number, we get the next number, next number, next number, next number, and so on. Now for the lower classes, what we can do? So we are teaching numbers for the lower classes. Say 1 to 100 is the limit. I won't teach beyond that. No educator will say, no student, no teacher will say like that. What comes after 101? What comes after 101? It is 102. So like that, we have to ask them inspirational questions so that we can test whether the number formation has been understood by them or not. So what we always do, instead of being in this manner, we ask them the reverse order. What comes before? What comes before? So before they get a clear idea of how the numbers are formed sequentially, we cannot ask the children this kind of what comes before questions will come little later. So they should know, even in class 1 or 2, when they begin to learn numbers, at that time itself we can tell them that numbers do not have an ending. We denote it by infinity. Definitely. So what comes after 1000? Give a bigger number. You give one number, I will give a bigger number still. Like that, there should be proper interaction among the children to read one to it. Number patterns. So by number patterns, what do we give? What kind of experiences we can give to the children? The number patterns are to be clearly understood. So what the using all the odd numbers, starting from the lower classes, the square number, then a particular number called Fibonacci pattern. particular number is called 121. What is so special about it? It's the first number of the Fibonacci pattern. What is 1331? It's the second number. How these numbers have come into existence? It just, what is the connection between the beehive and also here and mathematics? Beehive is nothing but the perfect hexagonal shape. It's a regular polygonal shape of 6 sides. So beehive and max is connected. And then similarly, there are some sunflower seeds. Sunflower seeds are arranged in a spiral form. At the right to left, they have got some particular measurement and following a golden ratio. So we get a beautiful blossoming of the sunflower after on seeing this arrangement. So like that, then finally it comes to number application. So we have to arrange the levels like this. First they should understand, then they should go for the formation, then they should go for the pattern, then they could go for the application. Finally, the application stage should come. So when we talk about the application, variety of application we can give to the children through variety of methodologies, variety of pedagogical practices. It always, there are many new pedagogical tools are introduced in every sector. And then lot of training programs are also going for applying this. So whenever we talk about numbers, and then how can you forget our Srinivasa Ramanujam? I would like to show this square before I conclude my presentation. What is so amusing in it? Can you tell me what is so special? You all know it. Magic square. What is so special in that? Here we are here to apply anywhere, wherever they see, whatever they see. So these are all adults. As educators, we can really see this and then be inspired. So this magic square, which row you
Ma'am, you have to unmute, ma'am. Rajeswari, ma'am, you have to unmute, please. Please unmute, ma'am. Yeah.
So this is Ramanujam's birth date.
Okay.
22/12/1887 is Ramanujam's birthday. And someone asked Ramanujam, what is your birthday? Immediately he gave this as the answer, 1887. See, how to form a magic square, how to arrive at this may not be an interesting topic for us. Maybe we have to work on and then we have to find out. But the way how to get the inspiration for such great people. There may be so many Ramanujams in our class. There may be so many Sakuntala Devis in our class. Just you tell a number, the Sakuntala Devi madam used to give the cube roots and square roots. So this is the way we have to, create an interest in the children. We have to create an interest in the subject. So this goes for a long way, so that the children will automatically take up mathematics for their future and they will become efficient leaders, efficient mathematicians in future. After Srinivasa Ramanujam, who else contributed to the world of mathematics is another Kaprekar, who is our own Indian. You know, some 1942s. He was born in Orissa on this number 2174 is called to be Kaprek's constant. In whatever way we arrange the 4-digit number and subtract, we will get the same number. So from this particular number 6174 is called the Kaprek's constant. There are so many inspirations like that. Let the children learn it. Let the children get the benefit of our. This is the way we have to definitely mathematize their minds, so that the children love the subject. The children are able to apply the subject in whatever, in all their works in life. So with that, I conclude my presentation. Hope I have not exceeded my time limit. Thank you very much, Raghuram sir. I feel very happy that I was able to share my thoughts. Only a glimpse of what
Thank
I
you.
wanted to say, I shared with you. Thank you so much.
Yes, ma'am. Thank you so much.